Determining the inverse, we know we always switch x and y. So we have x equals log base 3 of y plus 4 minus 2. And then we'll just solve using algebra for y. So let's add 2. X plus 2 equals log base 3 of y plus 4. To undo log base 3, we're going to exponential base 3 both sides. So we have 3 to the x plus 2 equals log base 3 and base 3 cancel out. Y plus 4, then we'll subtract 4. So 3 to the x plus 2 minus 4 equals y. And then now that y is alone, that's my answer. I'll put a little -1 on it to indicate that's my inverse. It says evaluate. So evaluate means calculate. So if you have a base 2 raised to a log base 2, it cancels out, you get 7. Base 6 raised to the log base 6 cancels out, you get 8. Base 3 raised to the log base 3 cancels out, and you get 4. As long as they're the same log base and base, they'll cancel out. Okay, it says write an equation equivalent to a log expression. So they're basically just saying rewrite this as a log. So if you have 2 to the x equals 8, you'd say, well, if they want this as a log, I need to undo the base 2. So I'm going to log base 2 both sides. So we have x equals log base 2 of 8. We know when we take a logarithm of a side, it then like traps the side, the stuff that you took the log of in parentheses. So that would be our answer. You don't even need to calculate it. It said write it as a log. So we're done there. So 4 to the x equals 6. We're going to log base 4, log base 4. So x is equal to log base 4 of 6. And this one, same thing. You would log base 5 both sides. So this would be log base 5 of 2. So pretty easy stuff. Combine the following into a single logarithm. So you know that this is log base 3, log base 3, log base 3. So you're going to write log base 3. But parentheses, if we see subtraction, we do a divide sign. Anything positive goes on top, anything negative goes on bottom. Remember, anything in front is an exponent. So we have a 5 on top. We have a c to the 6th power, c to the 6th power on top. And then because it's divide, it puts the a on bottom. Then same thing here. You'd say log base 2, log base 2. So you write log base 2, you throw in parentheses. Since you see a subtraction sign, you'll do a division sign. We're going to have a z to the 4th on top. And on bottom, a c squared. The reason it goes on bottom is because it's after the subtraction sign. So c squared. Any subtractions go on bottom. Any positives go on top. So this would be log base 7. That's not in a logarithm. This is a trick question in a way. So I'm going to just do it the easy way. And then there's a really more advanced way of thinking about this, but we'll just do it like the straightforward way. Log base 7, log base 7. So we're going to put those in the same log. And then this plus 2, we'll just add at the back. So then we would have an a to the 2nd power. I don't know why I did a division sign. There's no subtraction. So we have a to the 2nd power and c to the 4th. Make sure you understand there's always time signs between anything. If there's multiple things on top or multiple things on bottom, it's always a time sign. This one says expand the logarithm. When you divide, you subtract. So this would be log base 8 of base 8 minus log base 8 of x. And then you would understand that this is the same thing as log of 8. The change of base formula says that that's log of 8 over log of 8, which is just 1. So you would say 1 minus log base 8 of x, or you could just say, well, this is really log base 8 of 8 to the 1st, so they cancel out because they're inverse of each other, so we would have just got 1, just however you want to think of it. So we would have a log, we would have a log, is this a log base 8? I think so. Log base 8 of t minus log base 8 of s. This one we would have a log base 8 of s minus log base 8 of base 8, which cancels out to be a 1. So this would be log base 8 of s minus 1. All right, it says, what is the horizontal transformation? So we know this is shifted right 5, which just keep in mind means our vertical asymptote usually is at 0, at x equals 0. If we went right 5, our new vertical asymptote is at x equals 5. Just a fun little side note. To graph log base 6 of x, we would say to ourselves, okay, all logarithms have, unless they're shifted left or right, have a vertical asymptote at 0. And then to graph a log, we say, instead of calculating log base 6 of x, We would instead calculate its inverse, 6 to the x, and then switch our xy points. So let's plug in -1, 0, 1, and 2. Why not? 6 to the -1 is a decimal. So let me put it in a calculator real quick, just for graphing. 6 raised to the -1 is 0.1-ish. 6 to the 0 is 1. 6 to the first is 6. 6 to the second is 36. But don't graph those points. We're graphing the log, so we need to switch them. So we have the point 0.1, -1, 1, 0, 6, 1, 36, 2. So we go over 0.1 down 1, over 1 up 0, over 6 up 1. And then I know my graph of my log is a sideways exponential function. Trying to go through that point there. And then we could fill in the blanks here. So we see that it was 1, 0 and 6, 1.